Okay, so this is the explanation of the PowerPoint. I'm calling it Understanding General Patterns that Define Agroclimatic Regions. So the goal of this presentation is to bring the trainees uh, together to understand a series of parameters or variables that at the end we put them together to to the first we take the different parameters to understand the conditions of our agroclimatic regions and then see how changes on those parameters could affect the crops. So by this time they already have seen the introduction presentation in the morning. So I'm just giving a little bit of refreshment here with so this is the climatology, and here we see how the rainfall moves up and down on the uh, due to the ITCC, and that's the regular pattern during the year. So now we're gonna focus into Southern Africa, into Africa, and we're gonna start looking at the climatology for both rainfall and WRSI. We're gonna also look at the start of season and and the climatology for NDVI to get an idea how our region, the different regions behave. So we also are going to look at time series. We're going to look at the variability and then how all these things combined mm, could give us some possible implications in agriculture. So the first thing, this is the time series. So the first thing we're going to be using the map viewer to select different regions. First here in South Africa, and the whole idea is to get familiar with the characteristics of the different regions. In this case, we look at the climatology here down here, the rainfall climatology, and on the top the NDVI climatology. So we see that the season starts at the beginning of October and ends by the end of May, and the NDVI is telling us uh, how green the vegetation is, and it's always behind the rain. And in that previous image, we saw a single mode mm, rainfall pattern, and here we move into Kenya, and we see that the rainfall pattern changes. This is bimodal, and also starts in October, but it has a dry period in February, and it starts again and goes into June. And then we see that the NDVI shows the same thing. Then we move into West Africa. Just to let you know, this all these things are gonna be cleaned up. I need to redo the images. And here we see that the rainfall has a different pattern. It begins in April and goes all the way to November. So so then this is a way for us to look at the different patterns of rainfall throughout Africa. So let's focus on South Africa. Let's take a look at the. Let's go back and take a look at two different agro regions. The first one is right here in South Africa. It's giving us this information. We already talked about the 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 rainfall climatology, the rainfall patterns during the year, and then now we're gonna look at this region right here in Angola, and we look at it and we see that it's pretty similar pattern. It starts in October, goes all the way to May, And we see something different appear in the NDVI, that the NDVI is more consistent. It's about zero point 0.6 pretty much uh, the whole season, while the region right here in South Africa has a different pattern. So it's not as consistent as the other. It has a peak and it goes down again. So that's kind of getting an idea of how the our region behaves. So then a very important way that I think or a tool that is very useful is to see the time series for my region. So in this case, this is the time series. This is the total rainfall per season between 1981 and 2012. So here we see the characteristics of the rainfall for during that season for the entire history. So we see that it goes, and this is interactive. I asked the student, the trainees to define, to explain what this means, and then I bring the time series for the other area in South Africa, and then we start discussing what does what's the difference between the two, what kind of implications may be. So we see that this region is always pretty low. So whenever there is a small change in this region in South Africa, may be a big problem. But in this region in Angola, there may be a change like this year that's the lowest, and it went to just a little below 1,000. Even with that change, uh, it doesn't make much difference on the rainfall amount for the season. So that's the kind of uh, interaction that we're going to have. Then we look at the variability. We'll explain or go over what the standard deviation is, and then we see that the standard deviation of the two regions. So we see that they are not very different, but when we looked at the standard deviation in relation to the mean, which is the coefficient of variation, we see that the percent of the coefficient of variation for our region in Angola is very low compared to the coefficient of variation to the region in South Africa. So we see that the the region in Angola is very stable, while the region down in South Africa is not so much. So once we have that, so that's the explanation of the part on rainfall. So we want to understand how the rainfall behaves in these different regions. Then another way to look at our regions, or understand our regions, is to see how the rainfall is distributed during the season. The first part of the presentation just looks at the rainfall, and but it doesn't matter if the rainfall falls in a single month and then the rest of the months are dry. But now we're gonna see how the rainfall is distributed during the season, and that's why we use the WRSI, and and that helps us predict the crop performance during the season. So then we explain what the WRSI is, and we go over this. Then we look at the WRSI average, and based on the previous graph, we're gonna understand what this is telling us. Uh, I believe that the students will be doing some WRSI, at least going over the WRSI before this training, so this should not be very difficult. Then we go over the two regions that we are studying. Then and this is something that we're gonna do. I'm going to demonstrate how I calculate this time series just from the Excel file, so I will calculate it in there to demonstrate, because this is something that they're going to use in the exercise later on. So I need to show it. Then we look at the how the WRSI for my region in South Africa behaves, and so we understand and we describe what this WRSI time series means. Then we look at the WRSI time series for the region in Angola, and then we compare the two and discuss a little bit what they mean. Then we look at the so that's pretty much the whole presentation on understanding my regions, understanding climatology and understanding the time series to see to have a better mm, definition of our agroclimatic regions. Then we go into a case study, and for the case study, I'm going to use pretty much the same tools that we just went over to understand and see the implications on agriculture in a couple of areas in Guatemala. So we what we're gonna do is we're gonna define we're gonna select two regions. It's Escuintla in southern Guatemala and Totonicapan in the highlands. Then we look at the rainfall patterns. We try to understand. We see that they are uh, it is bimodal the rainfall season, and then we look at the means. We see what the means in Escuintla is and the mean in Totonicapan, and we look at the variation, and we see that the variation in the bottom is pretty large, but the mean is very big, and the variation up here is less, but also the mean is less. So at the end, the the coefficient variation is pretty similar. So that leads us to think that that the two regions are pretty similar. One gets more rain and the other one gets less rain, but at the end they vary the same. But then we introduce another variable that is elevation that is showing us a very different picture. We see that the region on the south is uh, has very low elevations. Most of the region is less than 700 millimeters, I mean meters, and the region on the highlands is very high. It's between 800 and 2,000 meters of elevation. This changes the temperature parameter, and this place is pretty cold, and this area right here is very warm. So that temperature changes the length of growing period in the two areas. So the length of growing period in the south is 9 decades, while the length of the growing period in the highlands is 18 decades. So this provides a great deal of information for us. So let's go back, and we see that the region on the south takes 2 seasons. So what this region does is they plant in late April or May, and they harvest in July, right before the midsummer drought. And then there's another season starting in late August or September. What that's in the south, while in the highlands they only have a single season due to temperature. So then when we go back to our the definition of the WRSI, we see that the requirements for the south are fulfilled right before the midsummer season. So they have a complete harvest, while the requirements for the highlands, they plant in May and they go all the way to November, December. So the midsummer drought is right in the middle of the length of growing period. So what we found that if there is any or if there is any problems during the midsummer drought, then this area is in trouble with the harvest. So we found that during the periods of El Nino, there is a decrease during July and August. There is a decrease of rainfall in the Pacific area of Central America. Then we see that a decrease in the highlands affect directly the midsummer drought, and it extends the midsummer drought during the Nino events. And does, it as we saw over here, it decreases the rainfall right in the middle of the length of growing period, and that uh, affects the crops. In 2009, there was a strong El Nino, and there were about 400,000 people at risk of food insecurity, and that is our case study. So what we've done, we described the regions, we understood what the rainfall does, what the agricultural aspects do, like the WRSI and the length of growing period, and then how that combined could tell us about the possible implications in crops with any changes in in any of those parameters. So then the exercise is we're going to have two regions from different areas, and so the students are going to select one of the two regions and as the region of interest, and we're going to ask them to describe the average climate. We're going to ask them to use Excel and to plot the um, the time series for both the rainfall and WRSI, and understand those time series, find when was the wettest year, the driest year, and look at the variability of the whatever the region they selected, and describe the possible implication on agriculture due to the variability and the time series of the two, the rainfall and the WRSI. Use mm, the map of WRSI average to describe the most vulnerable areas of the region of interest, and and I don't know if that's too long, but later on we go into the start of season if there is time. So that is, yes, there is a lot of work to be done by cleaning the slides and making them move correctly, and all the different to make it nice looking. But then this is the concept for the session one.